Hello guys, we're working on Chapter 5, OAW, Setup and Operation. Yippee skippy. Let's get started. Alright, so we're going to talk about putting on the regulator and the hoses. So the first thing we want to do is we want to crack the cylinder valve. We're going to open and close it really quickly. This allows us to blow out any type of debris or material that's stuck in there. Then we're going to make sure, or we're going to put our regulator on. We're going to make sure that there's nothing that's going to get in the way of us putting on this correctly. We want to make sure that we don't cross thread because we know this regulator is brass, and so are the fittings on our cylinder valve. Okay. We want to also make sure that the screw is, what do they call it? The adjusting screw is backed all the way out before we put any type of pressure on it. Okay. Then we're going to do the same thing with the acetylene hose, okay? And we're going to make sure, we're going to acetylene regulator, and then we're going to purge all the hoses, okay? Then we're going to attach it, the red for our fuel, that's acetylene, and the green is our oxygen, okay? And then we're going to slowly open our valves. When we open a oxygen valve, we're going to open it until it doesn't go anymore because it is a seating valve, which means there's two O-rings in there from the top and the bottom, and they need to seat fully for it not to leak. Now the acetylene is a little bit different. The most we want to go is 3/4 of a turn, and it will stay and not leak at whatever area that you keep it at. So we want to make sure that we can turn it off quickly. All right, numbering system. So ultimately, the diameter of the tip is the way they identify the tip size. So whatever size it is interiorly, that's what it is, a triple aught or a double aught. But this also gives us ideas of the types of pressure that we're going to use. Most of the time, we're going to run in this area, a 3-3 or a 4-4 area for oxygen and acetylene, because remember, we're going to use a neutral flame. That means it's a 1-to-1 flame. Okay, so here it is. Stand to one side and open the oxygen and acetylene cylinders. Remember, these regulators here have a safety. So that means if something happens, it's going to blow out, and it's going to blow out the face of the gauges or behind it. So we want to stand at arm's length away and open it slowly. So should anything happen, it's away from us. All right, we always want to point the torch down and use a striker. Why wouldn't I want to use a match or a lighter? Well, of course, they can always catch yourself on fire, and that little lighter can always blow up in your hand. We always want to point it downwards so that we don't light anybody, exclusively ourselves, on fire. All right, acetylene ignited. So we need to understand how to make the flame what it is. So let me talk about how we're going to turn the gas on. So what's going to happen is we're going to crack open the nozzle on our torch for acetylene, okay? And we're going to open it, and we're going to get it past, I call them the welding ferries. They call them parachutes. And there's these little black sooty things that come down. We're going to get a little past that, okay? And that's how much acetylene we need, okay? Then we're going to open up the oxygen, okay? And they say that we need a well-defined white cone near the tip. So what they're saying is this area here, right here, is going to be well-defined, okay? So we're going to be able to make a neutral flame. An oxidizing flame means there's an excess of oxygen. So when we've done this, we've set up our acetylene the way we have, and instead of making it just about the same as acetylene, we've gone and added a lot of oxygen, okay? The cone is going to go down, and look at the difference. So we're still going to have the acetylene, like it looks kind of orange and flamey on the end, but an oxidizing flame gets really short, okay? A carburizing or a reducing flame means we have an excess of fuel gas. That can be acetylene, that can be MAP gas, that can be natural gas, whatever we're using, okay? And it's going to be a lot oranger, and it's going to be a lot longer. We're really not going to be able to see too much of the cone, but it will be there. All right, points to remember. We want to make sure we properly secure cylinders because we don't want a bomb going off or even a rocket. We want to point the valve outlet nozzle away before we crack the cylinder because we don't want any oxygen or acetylene on ourselves, which can cause fire. We want to make sure that we test connections whenever there's a connection, whether it's at a tip or at a hose where the gas comes in or out. We want to use soapy water and check for bubbles. Okay. Now the welding tip size we know is the number is determined by the hole, but whatever hole we use or tip size that we use is determined by material thickness. So we need to remember 3 different rules. Rule number 1, match our base metal to our filler metal. Rule number 2, we want it as strong or stronger than our base material. And rule number 3 says 90% of what I do is dictated upon thickness of material. So we know that the thickness of material dictates the size of welding tip that I'm going to use. All right, we always want to stand to one side before opening the cylinder valve because if it blows out, I do not want a face full of gauge. We want to adjust the torch to a soft, neutral flame, that's a 1-to-1 flame, unless the type of metal requires a different type of flame. Prevent conditions that may cause a backfire or flashback. Ultimately, when we get a flashback or a backfire, it's because we have a dirty nozzle or we're depriving it of fuel, oxygen, or combustion. Okay? We want to make the passage in the welding tip clean, so we always need to make sure that we clean it. And when we clean it, we want to make sure that we leave the oxygen on and clean it so that it can blow out any soot. All right, why should cylinders be secured fastened between being used? Well, we want to make sure that they don't get damaged and fall over and somebody can possibly hurt. Why should the cylinder outlet nozzles be examined closely? Well, we want to make sure that there's not a damaged screw thread or anything like that. And if we have a poor connection, we're also going to lose gas, which means we're losing money. What is the proper order for setting up the welding equipment? All right, guys, here it is. Number 1, crack the cylinder valve by opening and closing them quickly to remove foreign matter. Number 2, connect oxygen regulator and hoses. Number 3, connect the acetylene regulator and hoses. 4, purge hoses. 5, connect check valves and hoses to torch. 6, test for leaks. All right. Why are check valves used? Well, check valves only allow the flow of gas in one direction, which means that flow of gas, if it ever combusts, it doesn't go back into our hoses and it doesn't go back into our cylinders, which can cause explosions. What is the proper method of testing for gas leaks? All right, guys, what do? Light a match. No, just kidding. We want to make sure that here's one way they say, to test for leaks, open the oxygen and acetylene cylinder valves. And with the needle valves on the torch closed, adjust the regulators to approximate working, pressure. And then put soapy water on the oxygen cylinder valve, the acetylene cylinder valve, any type of inlet connections, hoses, and anything that, the needle valves on the oxygen and acetylene. So all of those different areas are what we want to look for when we look for leaks. All right, what governs the size of the welding tip that should be used? Drum roll, guys. What? Thickness of material. Describe the process for lighting and adjusting the flame for a torch. It's not going to be for a cutting torch, it's be for a welding torch. There's a type of one here. All right, number 1. Select the correct welding tip size for the metal to be welded and connected to the torch, which means making sure the thickness of our material is comparable to the tip size that we're using. Stand to one side and open the oxygen and acetylene cylinder valve slowly. Set the working pressure of oxygen and acetylene regulators, adjusting valves to correspond to the required working pressure of the welding tip. Turn the acetylene needle valve on the torch approximately 1/2 turn. With the spark lighter in the hand held about 1 inch away from the end of the welding tip, ignite the acetylene as it leaves the tip. Adjust the acetylene until the smoke disappears. The acetylene needle valve on the torch should be turned approximately 1/2 turn. Well, that was about it. Okay. All right. How far should the acetylene needle valve be opened when lighting the torch? About a 1/2 turn. All right. What is an oxidizing flame? An oxidizing flame has an excess of oxygen. What is a carburizing flame? Well, it's also called a reducing flame, and there's an excess of fuel gas. What's the difference between a neutral flame and a carburizing flame? A neutral flame has neither oxidizing nor carburizing characteristics. The brilliant white cone should be approximately 1/16 to 3/4 inch, depending on the welding tip size. Oh, well, I think I skipped one. Oh, geez. Okay, what's the difference between a harsh flame and a quiet flame? Well, a harsh flame means there's too much pressure of both gases and it makes it really loud. Quiet flame means it's appropriate for the tip that we have. What causes a backfire? A backfire can be caused operating the torch at a lower pressure than required for the tip, touching the welding tip against the work, overheating the tip, or an obstruction in the welding tip. All of those things can cause problems. All right, what is meant by flashback when we're using an oxyacetylene torch? A flashback is the recession or the movement of it into the mixing chamber of the torch itself. And you'll hear, okay? A flashback flashes quickly into the torch and it burns inside. It gives that hissing and squealing sound, and it's because a welding tip can be clogged, the needle valves be not right, or the pressures are incorrect. Okay. Why are hoses purged after being connected to the regulators? Well, we want to make sure that there's any dirt or anything lodged in there, that they come out before we attach them to the torch. Okay. Why should the welder stand to one side when opening cylinder valves? Well, we don't want to face full gauge. And if we're cracking our valves, we also want to make sure that we don't get it on our clothing, because it gets into the little particles of our clothing, and those little pieces and porous areas, if they're subjected to any type of spark, well, kaboom. All right. Remember this, guys. What is the last step done to the regulator when shutting off the torch? The last step is to release the adjusting screws on the pressure regulator. That means I've closed everything else off, I've bled off all of my stuff, and now I'm taking these pressure screws where I set up my pressure at and I'm backing them off. It's really important. All right, I think this might be it. I'm not sure. There we go, one more. Oh, sorry guys. One more. Last one. All right, what kind of mixture of oxygen and acetylene is required to achieve a neutral flame? That would be a 1-to-1 mixture. What happens when an oxidizing flame is used to melt the metal? Well, it'll give off a lot of sparks, and sometimes it makes like a white foam on the surface, and then when the piece cools, the metal will be really super shiny. All right, guys, take care, be safe.